you develop an ionic name from an ionic formula. Hopefully you looked at the previous video to figure out whether your compound was ionic or covalent. Hey, let's do a quick recap. If it's an ionic compound, it's going to start with a metal or ammonium. Okay? So now that you know that your compound is ionic, let's go through the steps to determine the name. There are actually two different types of ionic naming, and it all centers around this step. If the positive ion can have multiple charges. Okay, let's talk about that. If you remember, when we were talking about transition metals, we realized that the transition metals, most of the time, could never have a noble gas configuration. Because of that, a lot of the transition metals can take on a couple of different charges. I'm going to focus your attention on 7 of them. So let's do that. Chromium, manganese, iron, and cobalt can have a 2+ or a 3+ charge, very commonly. Copper can have a +2 charge or a +1 charge. Tin and lead can have a 2+ or a 4+ charge. So when we go to naming those, there needs to be an indication of which one you have. Okay, let's go back to type 1. In type 1, you don't have one of those 7 metals that I brought your attention to that could take multiple charges. Most of the time you have an alkaline metal or an alkaline earth metal, maybe aluminum. Okay, so let's get started. I'm gonna work with this first compound here, and we'll just go through the steps. First of all, it says separate the positive ion from the negative ion. Okay, well, sodium's my positive ion. I'm going to separate it from my negative ion. Remember, keep the subscripts with the element that they belong to. Doesn't matter so much in this instance, but it does in other instances. Then I'm going to write the name of the positive ion first.
If you requested 2 boxes.
Okay, write the name of the positive ion first. The positive ion in this instance is sodium. Then it says, if the positive ion can have multiple charges, add a Roman numeral to indicate the charge. You will have to balance charges. This means that the positive charge equals the negative charge. Okay, we don't have one of those in this instance, so we can just go on and go to step 3. In step 3, it says, write the root of the negative ion with an IDE ending, or the name of the polyatomic ion. Okay, no polyatomic ion here, so all we have to do is write the root of the negative ion, which is going to be ox, for oxygen, and an IDE ending. So this is sodium oxide. Let's try another one. Again, if we look here, we're going to separate the positive ion from the negative ion. We're going to write the name of the positive ion first. In this case, it's calcium. It is not one of those metals that can take on multiple charges, so we skip to step 3. Write the root of the negative ion with an IDE ending, or because we have 2 elements here, we know that this is a polyatomic ion. CO3 is carbonate, so this is calcium carbonate. Now all you have to do is just write the name of the polyatomic ion straight up. Let's do another. All right, so remember I said make sure that you are aware that if you start with N, you've got to look for H4, because anytime you have NH4 starting a compound, that's ionic. So we're gonna separate that here. Write the name of the positive ion first, that's ammonium. And then write the root of the negative ion with an IDE ending. That's ammonium chloride. Let's do another. Separate the positive ion from the negative ion. Again, if you've got parentheses, it is a dead giveaway that you've got an ionic compound. So we don't have to worry about the subscripts. So Al is aluminum. And SO4 is, so I'm looking in here only. This just tells me how many polyatomic ions I have. My polyatomic ion is sulfate, so this is aluminum sulfate. All right, so that's how you do type 1 ionic naming. First, you just separate the positive ion from the negative one. Then you write the name of the negative ion. If it's single, it has an IDE ending. If it's a polyatomic ion, you're going to have an ATE ending or an ITE ending. Have a great time.